talking about oxidation of alcohols, which was that the alcohols would there was primary alcohol that would get oxidized to an aldehyde, and which would further get oxidized to a carboxylic acid. And then you had secondary alcohols, which we did not do. Secondary alcohols are alcohols that have two carbon chains. So let's talk about secondary alcohols now. Secondary alcohols are the ones where the alpha carbon is attached to two carbon chains. So there's only one hydrogen next to it. So there's carbon and there is OH, and on two sides there is a carbon chain, and on one side there is a hydrogen atom. Now the oxidation of this alcohol is that it would change into a ketone. It's going to form a ketone. It's the carbon, and remember the change that would happen to the alpha carbon. Nothing happens to the rest of the molecule. It would just simply change into a ketone. The OH would disappear, and there would be a double bond O that would be formed over here. So ketones would be formed in this reaction, and ketones are relatively stable to oxidation. The reagents that are used are going to be the same one. It's either K2Cr2O7, acidified and reflux, or the other one is that it's going to be KMNO4, which is going to be acidified, and that would be reflux as well. Okay, so you have two reagents. So you have a secondary alcohol, and it's going to get oxidized the same way as a primary alcohol gets oxidized. But a primary alcohol turns into an aldehyde. I mean, it also changes into a C double bond O. This one also changes into a C double bond O, but since the carbon is somewhere in the middle, which is why it's actually turning into a ketone, not an aldehyde. And no further oxidation is possible for a ketone. And then you have tertiary alcohols. Tertiary alcohols don't go undergo any oxidation. So you have a tertiary alcohols, and tertiary alcohols are resistant to oxidation. So they are resistant to oxidation. What's a tertiary alcohol? It's going to be that there's going to be a carbon with an OH, and on all sides they are going to be carbon chains. So there would be no hydrogen attached to it. So that is what a tertiary alcohol is. So no oxidation for tertiary alcohols. Now there's one other thing, and that is reduction. We talked about oxidation, and since we are dealing with this, we can also at the same time uh, talk about reduction. Uh, the reduction is exactly the opposite. So I mean, for the same molecules, let's draw the same chart for reduction. Okay, it's going to be the reverse of what we did above. So let's say you have a carboxylic acid, which is RC double bond O and OH. The carboxylic acid changes into an aldehyde back again, and the aldehyde changes back into an alcohol. And again, it's the alpha carbon, not the rest of nothing happens to the rest of the molecule. It's only the carbon that was forming the carboxylic acid functional group. Only that is the one that's changing. So eventually, it's going to form a primary alcohol back again. So what you're going to do is you're going to change it into this carbon over here. ठीक है, the one that I'm trying to highlight. ठीक है, just keep changing that. From a carboxylic acid, it changed into an aldehyde and it changed further into an alcohol. Now, to change the reagent, what's the reducing agent that would be used? That is LiAlH4 over here, and over here you could use NaBH4, or you can also use LiAlH4. Uh, so these are your two reducing agents that would be used. Okay, I'm going to write that these are your reducing agents. Now, LiAlH4 is kind of a stronger reducing agent compared to NaBH4. But that information probably it's not going to be helpful anyway. You just need to know that LiLH4 is used to reduce carboxylic acids. Acids are kind of more difficult to get reduced, which is why you kind of use a more powerful. It's the same as using K2Cr2O7 and KMnO4. I told you that K2Cr2O7 is recommended. KMnO4 is kind of slightly a more powerful oxidizing agent. So the same is the case over here that LiElH4 is a stronger oxidizing agent. NaBH4 is slightly weaker reducing agents. So these are your reducing agents that you're going to use. And and just to give you an idea of how they work as reducing agents, both of them. ठीक है, but let me draw the other one as well. A ketone, if you have a ketone, that would change into so that is going to change into a secondary alcohol. So it would change into RC, and there would be OH and H. It would just change into an alcohol. The carbon would change into an alcohol. The reagents that would be used would be LiLH4 or NaBH4. Now, there's one other reducing agent that could also be used, and that is simply because you're trying to add hydrogen. So, this is number one. Another one that is usually not used but can be used is that's nickel plus hydrogenation plus 150 degrees centigrade is the temperature. So, this one not recommended, but it can also be used. So, I'm going to put that in brackets. So, if they ask for a reducing agent, you write NaBH4 or LiLH4. The same is true over here. The other one that you could use over here, this is number one. Number two would be nickel plus H2 plus 150 degree centigrade temperature. Again, I'm putting it in brackets. This could work, but not recommended. So, oxidation and reduction. Uh, these reactions are going forward in the forward direction. Okay, let me. So these are the ones that are going in the forward direction, and the exact reverse is this thing. So you must remember your reducing agents as well. So I'll just give you a brief idea of how reducing agents are going to work. For example, if you're trying to reduce a ketone, this NaBH4 or LiLH4, it has the Na and Li are kind of not very relevant. Let's talk about BH4. Now BH4 is that B has three electrons in its outer shell, so it forms BH3. But there is one orbital that is empty, so the H minus one ion comes in and ends up forming a dative bond. Like boron's outer shell has only six electrons. Boron has three electrons. It attracts three hydrogens, bonds with them, so it now has 6 electrons, but one of the orbitals is completely empty. So an H minus 1 comes along and forms a dative bond. Now this BH4 minus 1 or the AlH4 minus 1 ions, they are a source of H minus 1 ions. I mean, they're capable of producing H minus 1 ions because this BH4 minus 1 ion can, at any point, the dative bond might break and it would result in the formation of the BH3 molecule, and the H minus 1 ion would be formed. So this is what's happening. Now, why does the H minus 1 ion act or reduce a ketone or an aldehyde or a carboxylic acid? Now, the reason why it does that is that if you let's look at a ketone. They all have a C double bond O group, and the C double bond O group is highly polar. TK, Ethan, Mohammed, can you hear me?
Yeah. Yes.
TK, is the structure of BH4 clear? Isaiah, is this clear?
Yes, sir.
Yep.
TK, I'll just go into a little bit of further detail. Like boron has 5 electrons. Its outer shell is having just 3 electrons, and the 2pz is actually empty. So it attracts a hydrogen over here, pairs with a hydrogen over here, pairs with a hydrogen over here. So 3 of its orbitals get filled. The fourth one is still empty, so a dative bond is formed. And so now what happens is, why do anything with a carbon double bond O, why does it get reduced? Because it's a polar bond. So the reason it's going to get reduced is that the H minus 1 ion is going to be very strongly attracted to this positive carbon. And as a result, the electrons in the double bond are going to get repelled. So the next thing would be that the molecule that would be formed would be RC. The H would bond over here, and there's going to be R, and the double bond is going to break, and O minus 1 is formed because the double bond electrons are going to get repelled. And since there is water and there's H plus 1 ions roaming around in the solution, the H plus 1 would then come in and then bond with the O, which is minus 1, and they would end up forming OH. And that's how alcohols are formed. That is how a reduction happens, that the H minus 1 starts attacking the positive carbon atom in all these cases. TK, I mean, look at all the carbon atoms. They all have a positive, partial positive charge. There's cetyl bond over here, cetyl bond over here, cetyl bond over here as well. TK. Is this clear, Isa, Ethan, Mohammed?
See.
So there's H plus ions and H minus ions.
The H minus 1 ions are actually coming from BH4 minus 1. I mean, that's your reducing agent. The other H plus 1, they might come from water.
Also, they're present at the same time.
Yes, I mean, originally this molecule would not attract the I mean, the carbon would not attract H positive because it's positively charged.
Oh, okay.
Okay. And it's not, I mean, I just made a shortcut. It's not actually H plus 1. There might be water molecules around, right? And water molecules, the H is positive, and so what would happen over here is that the electrons will attract the H positive, and because of the negative charge over here, the electrons over here, they're going to get repelled. So the bond, I mean, the O minus 1 can attract the H plus 1. Once an O minus 1 is formed, it can attract an H plus 1 from anywhere. Okay, it's going to pull H plus 1 out of atoms. So is that clear?
Yep.
Okay, so I mean, this is not very important, but there have been, I mean, it's not in your syllabus. I mean, this is acting as a nucleophile, but you've been actually asked questions about this. Okay, so So the mechanism that's happening here, that's kind of not important, but you've been asked questions about it. Uh, okay, let me, because sometimes what happens is they're going to ask you questions about things that you haven't studied, and they're basically looking for you guessing how things are actually working. So, so not in syllabus.
So is it nucleophilic addition?
Yes, it's going to be nucleophilic addition, and we're going to do nucleophilic addition after that when we study aldehyde and ketones, right?
Okay. All right.
So, so these charts over here, the reduction and the oxidation charts, uh, they are very, very important, and you have to identify. So I'm just going to open a worksheet now. Just a second. Okay, we're going to do questions related to alcohols.
Sir,
Yes.
for the conditions for like all the functional groups, is there like an easy way to remember it, or do we just have to memorize everything?
Need the conditions?
Yeah.
I mean, there is an easy way to remember. Just one second. I'll just show you. Uh, ठीक है, I've actually opened the. ठीक है, for example, there's this one. I mean, what you can do is you can make a chart like this, and we're going to do that in the end eventually. But the thing is, uh, I mean, for example, over here, you have an alcohol. It's undergoing oxidation. You get an aldehyde, which can further get oxidized to a carboxylic acid. Uh, and there would be an alcohol getting oxidized if it's a secondary alcohol. That's two. That means secondary. So that's getting oxidized to a ketone. Uh, so I mean, there's this chart that I've made. I'll share this chart with you. It has all the relevant conditions. Uh, but then there are other details also that are very important. But this chart is going to help you with remembering the conditions. I mean, the O over here, if you look over here, the O over here is the oxidizing agent, which you can see over here at the top. That's KMNO4 or K2CR207. And then you have your reducing agents. The H represents like the reverse. So, Ethan, do you get the chart, right? I'm going to send this,
Yeah.
and you can keep it with you. Uh, so, if you have it written in on one piece of paper, it would kind of become easier to remember. And it would become easier to actually remember all the other stuff as well. Like if you look at alcohols, primary alcohols, I mean these 1 degree alcohols getting oxidized to aldehydes, uh, you might remember other stuff as well. Okay, you'd be able to recall and make connections with this. I said, oh, anyways, didn't mean to open this one. Just a second. I said, so, okay, this one. Let's try and do this. The first question is which one? I mean, you just have to identify a primary alcohol, a secondary alcohol, and a tertiary alcohol. Can you try and do that? Which one is a primary alcohol out of, I mean, which option is correct? Anyone? Mohammed? Ethan? Isa?
Um, I'm still doing, but I think it's D.
think it's going to be D because this one is a primary alcohol, one carbon chain. This one has and remember the alpha carbon, the one that has the functional group, whereas this one has three carbon atoms. The next one is the next one is the question is that it's reacting with KMNO4. There's an organic compound that's reacting with KMNO4, but will not decolorize bromine. So if it's not reacting with bromine, that means it's not an alkene. But it is getting oxidized by KMNO4. So which one is it?
Is it B?
I think it's going to be B because alcohols and ethanol is a primary alcohol. They're going to get oxidized. Now the next one is just 1 minute break. ठीक है? As I said, let's try and do this one. Which alcohols on oxidation with acidified potassium dichromate 6 gives an organic product which causes an effervescence when reacted with sodium carbonate? So, so the product is reacting with sodium carbonate. What do you think the product is? I mean, there's oxidation that's happening.
Uh, Carboxylic acid.
So basically, you're looking out for a carboxylic acid, right? Now, what would be the original alcohol? Is it going to be a primary, secondary, or tertiary alcohol?
Primary.
So it's going to be a primary alcohol. So basically, looking for a primary alcohol because only they produce carboxylic acids. They turn into aldehydes and then they turn into carboxylic acids. So which one do you think is a primary alcohol? For you have three options: one, two, and three.
One.
So one is a primary alcohol because it's butane one all. So uh, that means the OH is over here. So this carbon atom over here is bonded to two hydrogens, and on one side there's a carbon chain, right? So one is definitely a primary alcohol. What about number two?
It's a secondary.
It's you would have to draw it just to be on the safe side. So it's propan one all, right? Like it's propan one all. So that's three carbon atoms. One all means That OH is on the first one, and it's 2-methyl, which means that the second carbon atom has a methyl group, right? But but remember, that this is your alpha carbon, so it's attached to two hydrogens, and there's a carbon chain on one side. So that's your primary alcohol. Ethan, Mohammed, is this clear?
Yep.
Yep.
Yes.
So what about the third one?
It's
A secondary.
The third one, Rock, I think it's propan 2 all right. So it's three carbon atoms. 2 all means there's an OH on the second carbon atom, okay? And 2 be methyl है, there's a methyl at the second one. That's so focus on this carbon atom, the alpha carbon,
Tertiary.
okay, on all three sides. So that's a tertiary alcohol. This is not going to get oxidized. Um, and these two are primary alcohols. Okay, is this clear?
Yes.
Yes.
I said next one is there's a compound hex 3-ene 1 all, and it has a strong leafy smell. I said it's basically saying what happens when it reacts with KMNO4. Now this has multiple functional groups. It's an alkene as well as an alcohol. What kind of alcohol is it?
Primary.
You-
primary.
This one is a primary alcohol. So it's going to change into a carboxylic acid. So this one will get oxidized into a carboxylic acid. But what happens to alkenes? If you remember alkenes, this is strong oxidation, hot KMNO4. That means strong oxidation. Now in alkenes, what would happen is like it's CH3, then it's CH2, then there was CH, and then you had a double bond, right? Now in alkenes, the double bond would break. And when you got a carbon chain on one side and a hydrogen on the other side, this would change into a carboxylic acid. So you will get propanoic acid, which is going to be this one, right? It's going to be a propanoic acid. And the other side, what happens to the other side? It's going to be double bond, and then there is H, and then there is CH2, then there is another CH2, and then there is OH. So what happens to the two carbon atoms? This one changes into carboxylic acid, and then there is CH2, and this other carbon atom, which should be this one, it also changes into a carboxylic acid because it's a primary alcohol. So it's going to give you this molecule over here. Okay, is this clear?
Oh, could you repeat the part where the alkane changes to carboxylic?
Remember, we did oxidation of alkenes. There were three ways. Like if you do oxidation of alkenes, the double bond is going to break completely. Strong oxidation. And you had three options that if there was a carbon chain attached to the double bonded carbon atom and just one H, this would change into a carboxylic acid. If there were hydrogens attached, it would change into a carbon dioxide molecule. And if there were, do you remember that part?
Not really.
Just a second. Let me. So you probably did this before halogenoalkanes. This is halogenoalkanes. Before that, we were doing alkenes. This is still. No, this is still halogenoalkanes. Now, before this, this one. Okay, we had ended alkenes with this strong oxidation of alkenes. And we did a worksheet on it as well. Then I told you that when you have an alkene and you use hot concentrated or acidified KMnO4, what would happen is that the double bond is going to completely break. And when the double bond breaks, changes would happen to both of these carbon atoms. The molecule would split at this point. And the carbon, if the double bonded carbon had two hydrogens attached to it, it would change into a carbon dioxide and a water molecule. If the alkene double bonded carbon is bonded on one side with a carbon chain, on one side with a hydrogen atom, then it would change into an aldehyde and then a carboxylic acid. And if there were carbon chains on both sides, it would change into a ketone group. And we did a few questions. We did a worksheet as well. Like if strong oxidation happens to this molecule, the double bond over here is going to break, and if the carbon over here is bonded on both sides by carbon chains, then it would change into a ketone. As you can see over here, if the carbon is only connected to one carbon chain, that would change into a carboxylic acid. And this carbon over here, that would change into. So we did these questions. Ethan, do you remember this?
Yeah, I do.
Okay, so this is exactly what's happening with our worksheet go. So this is exactly what's happening here. Like if I draw the entire chain, I mean, I just need to this carbon atom over here, the one that I'm highlighting, this one is only bonded on one side by a carbon chain, and one side there is H. So if there's one H, that would change into a carboxylic acid. So the same is true for this one. This would change into a mic on है किसी का Aisa?
Samira.
अच्छा, so this would change into a carboxylic acid. This would change into a carboxylic acid. Since this is a primary alcohol, which we just did, it also changes into a carboxylic acid. So is this clear?
Yes.
Yes.
So let's do some more questions on oxidation. Now the question is, which alcohol gives only one oxidation product when warmed with dilute when you oxidize it, right? All of them are alcohols. Can you tell me what would be the oxidation product of butane 1-ol? Is it a primary alcohol or is it a secondary or a tertiary alcohol?
Primary.
So primary alcohols are going to change into aldehydes, and then they're going to change into carboxylic acid. Now the problem is you might not get a single product. You might get multiple products. Like you might get an aldehyde and you might get some carboxylic acid. So that's going to give you multiple products. What about this? What about this alcohol? What type of alcohol is this?
Secondary.
Okay, this one is a secondary, so it's only going to give you ketones. So B is going to be your answer. What about the third one? What type of alcohol is this?
Primary.
Primary.
This one is a primary, so again you're going to get aldehydes and carboxylic acids. What about the last one?
Tertiary.
You get tertiary alcohols; they don't get oxidized in the first place. So hence the answer would be option B. Uh, Now this one is saying, let's talk about oxidation of alcohols. So what can be produced when aqueous solution of butane 1-ol is heated with dilute acidified? So you would get an aldehyde, you would get a carboxylic acid, but you're not going to get a ketone. This is going to be incorrect because this one is a primary alcohol. Okay, so you'll get aldehydes, you'll get carboxylic acids, but not ketones. Is this clear?
Yes.
So let's continue with this in the next class then, okay?
Sir, I have a
Yes.
question. For the mechanism for reduction of alcohols,
Yeah.
how does the H become negative again?
In the BH4 ion, it's already negative. Like the BH4 minus one, I mean the ion, the reducing agent, BH4 minus
Oh,
one,
yeah,
it's NaBH4 or LiLH4, right? In both of them,
yeah.
the H is already negative.
So, um,
So you would have to add them to get the negative ions. Otherwise, you won't have negative ions.
so the BH4 ion is already negative.
Yes, I don't know where the worksheet is. Uh, it's NaBH4. Na is plus one, BH4 is minus one.
Yeah.
So it's already. I mean, this is the BH4 minus one ion. So you get H minus one out of these. Okay?
So one of the H atom
Breaks away.
leaves the BH.
Yeah.
Or
So it already has excess electrons, which is why it has H minus one, and that's why this is the reducing agent.
no. All right. Thank you.
Okay, then take care.
Sir,
Yes.
so what type of fission is occurring for
Oh,
this one?
this is probably heterolytic fission
Oh,
because
okay.
the H is taking away both of the electrons. I mean, both of this was a dative bond in the first place, which meant that both electrons were coming from the H minus one ion in the first place.
Oh, okay.
Because boron had an empty orbital, so there was room for an extra pair of electrons.
All right.
Okay, okay then.
All right. Thank you.
Allah Hafiz.
Enough is-
Thank you.